here on the board. Again, that does not mean that we could not repair it, but it is a question of money. I mean, it is an old radio, and you know, there are TYT units on the market, quad band radios for, I don't know, $250, euro, whatever, and that is much cheaper than to fix this old radio. But anyways, let's check what's really going on here with our incoming signal, and when we know where we are losing our signal, or finally if it is passing through, then we can decide how we really go ahead. Okay, so what I gonna do right now is I want to probe here our incoming signal right here out of the duplexer, and we should see I've set here our generator to minus 70 dBm, and I should be able to read our minus 70 dBm here at the input to our amplifier board, or if you will, the output of our duplexer, and then I want to see if we can finally see here our signal down at the connector to the main board. So this both tests I want to do, and then we go ahead. Alright, so here we have our spectrum analyzer screen, and now I go down here to the output of the duplexer, or to the input of our amplifier board. So let me go down here, and yeah, so what we see is that we really have our minus 70 dBm with 145.525 megahertz. So that means the carrier without modulation is at the right level. That is fine. So now let me go over to the input, to the main board, and that should be here. And okay, we lost 1 dB, but that is fine. And let me see if you can see it here. Okay, so that means we have our signal here, and the conclusion is we have a problem here on the main board for sure. So that means we have two different problems on the main board for receive, and here on the power amplifier board for transmit. So two faults in an old radio always means that we really need to think about if it makes sense to repair such an old radio. So therefore the best is to talk to the owner to decide how to proceed. Anyways, let us do one more additional test to have more where we can talk about with the owner. I mean, we have here this power source unit, and we have seen that this FB output of the power source unit should be directly connected to our amplifier board. And let us see physically the board, this power source unit, and let's check if we have our 13.8 volt out of this board. I mean, this is important to know, because then we can confirm that the drawing we have here is not one-to-one what we have here on the board. So maybe two different versions, as I already said. Yeah, so let's do that. Okay, so therefore I have to flip over here our radio. Let's see if you can see it. Okay, and our power board is really down here. You see, you can get it in a little bit better, but yeah, so that is what we have, and I don't know if we can see it, but down there, let's see. Yeah, it is hard to see. It is hard to see. Maybe that way. No, not really. But anyways, this brown wire here is the FB. So that is what I was able to read on the board. And I'm now interested. If I go down here to the FB solder point, exactly down there, yeah, and I already can see it. So down there we have our 13.7 volt, which is going to somewhere. I mean, according our schematic, it should directly go to the power amplifier, but as we have seen, it doesn't. Yeah, hard to say how to proceed. Shall we go and gather more informations, or should I stop here and talk first to the owner? Okay, so I lifted this board here up to get access here to our UHF module, and what you see here, this is our FB wire, and it is here going to the UHF module, and so the UHF module directly gets supplied with our 13.8 volt, so hope you can see it. And then we have here a bridge wire, and I believe it should go over here to our VHF module, but it does not. So therefore next step would be I need to take off here this board, or VHF board, to see what's going on here. But yeah, to be honest, that is far too much what we do for the moment in time, as we need to decide how to proceed. Okay, I stop here and I talk to the owner, and then I will come back, and then maybe we see that we go ahead with this radio, or simply we stop here because it is from an economical point of view, it does not make any sense to repair such an old radio. Okay. Alright, and okay, so we decided to go one step forward, just to be able to have a better idea what's really going on here. So to make a final decision, we will replace here our resistor, and let's see if this is doing the trick. If yes, maybe it makes really sense to go ahead. If not, then we have to assume that really something is wrong here with our power module, and that definitely means $70 or euro for a module and a radio of this age, so that does not make sense. Okay, so let me simply take out here our VHF power PCB, and let's see what will be happening after we have replaced here our burned resistor. Okay, so I've lifted here our board, and yeah, when we go here closer, you see we have here our next burned component, so that is C17, so that is, yeah, it is definitely completely burned, our C16, and yeah, let's have a look where we find it here on our schematic to understand how it hangs together. And again, here is our final VHF final board, which we lifted a couple of seconds ago, and we have here our R11, so that is a resistor which burned out, and our C17 is right beneath. So let me enlarge it that we can better see it. Okay, so here we have it. So here is our R11, and this is our C17. So that is obvious, 1 nanofarad resistor, and yeah, the R11 is burned, so maybe that the C17 shorted out, and that means it is then simply a short to ground, which would finally burn the R11 as well. And yeah, to see it once again, so that is our transmit voltage. So always when we press our PTT, we have here our switching voltage. So that is 8 volt transmit VHF, and you see that is here the pass over our L6 and L5 to pin 5, but we know we have a different final in our circuit, and that is finally where we have to put our second DC voltage. So this drawing is wrong, or as we already discussed, it is different, older, newer, whatever version. Right, so that means we have to replace both our resistor R11, our 150 ohm resistor, and of course here our burned C17, and if we are really lucky, we can have a little bit hope here that it really was only this SMD capacitor which simply shorted out to what reason ever, and that this shorted C finally killed our resistor, and that our final stage is still fine. So yeah, let's swap it out, and then we will get definitely a better idea what's going on here. Right, so we have here our new capacitor in, and of course we have our new resistor in. So it was a half watt required, and I put in here a watt. So I don't know if it is permanently getting a bit too hot, but that is then, if that is the case, and if that might have been a problem. This is definitely solved by the 1 watt version I put in. Okay, so let's put it together and yeah, let's see if these both components are doing the trick. Okay, so all is back in so far. So let me connect here the radio to the power supply, and you see that obviously was successful, so no problem. Let me see. Static is there, but we want to check out if we get here any output power, and therefore, yeah, I have switched here the radio again to low power, and that is what we had before as well. And let me go here a little bit closer, and let's see if something happening now. Okay, so we have still our 5 watt, so that is what we had before as well. So let me reposition the camera that you can see our test, right? Okay, so that is much better. Okay, so let's check here again our 5 watt. And you see 5 watt is given, and obviously modulation is also present, so that seems to be fine, and 4.7 watt, so no problem whatsoever. But now the minute of truth, so let's switch to high position. And yeah, let's see what we have now. And wow! So really our radio is back. It is definitely back, 38 watt, which is definitely fine. As far as I remember, radio is rated on VHF with 40 watt output power, and that means yes, it is definitely back. So now, of course, we have to look after our receive problem. But first, once again, here a closer look to the board, and of course you see here our new resistor, and by the look at it, it seems really so that the little capacitor shorted out, and the shorted out capacitor took finally the resistor as well, and that was the reason why everything was definitely down here. So that of course is a success, and okay, let's go ahead. Such an old radio, unbelievable. Okay, let's look after our receive problem. Okay, so I've taken the VHF mainboard here out of the circuit. Unfortunately, I cannot connect here, all the connectors to the board and then bring it into a position that I will be able to do here some tests, and yeah, we are running out of budget here with this radio, so that is a little bit a shame, but it is definitely an issue, right? Well, what I have seen so far, so I was hoping that maybe there is also a burnt part, but no, it is not. But what I found is that for any reason, here is a modification on the board, and you see here that we have here a package soldered over here the normal components. Okay, so that looks to me like a modification, and we see here the Q1 with is a little front end dual gate FET, and then this kind of modification. So now I really would need to solder to all these points some extra wires to take measurements, but as I said, we are really running out of budget, and now it is getting more and more funny. So the only thing I have recognized, but I'm not sure if it is good or not, because according to our schematic there is a coil somewhere, so that we have here at this component, you can hear it, so there is really a short in all directions, and that is definitely a little bit odd, but as I said, there is a coil connected here to these points, so I'm really not entirely sure if this is normal, that this component shows behavior as short. So the last I could do is to take this component off and see how the board or the circuit then reacts. But yeah, let me show you the schematic that you know what I'm talking about. Yeah, again we have here of course our VHF main schematic diagram, and let me zoom in here a little bit. So here this point we have tested with this point here, where we tested with our minus 70 dBm to find out if the signal is coming over our amplifier board, and we found that the signal is fine at this point. Then of course we have here some diodes, and I was able to check these diodes, and it looks like that these diodes are fine, so no problem. Okay, and then we have here our front end transistor, and now for, I would say, a modification, we have soldered here, somehow we have soldered here a dual diode pack over it. So as I said, it looks to me like a modification, but it is nothing mentioned in the schematic, and Alinco products are not so many on the market, so I do not have a reference to check against another unit, so that is definitely a bit of a shame. So what I can do, or yeah, let us have a look here onto the board plan I have, and what we can see here is let's see. Okay, so what we can see here, this is our Q1, so that is a little dual gate FET, and we see here the diode packs which are in the front end circuitry, but here on the board on this plan, we definitely do not see a dual pack diodes, so nothing. And when we go back here to reality, once again we see that we have here our little dual gate FET, and that is a double pack. So to me it looks a little bit, as I several times said, a modification. So and when I go with my beeper on this component, it shows short in all directions, but as I said, there is a filter coil. Maybe it is where are we? Maybe it is this one here, maybe. Anyways, one of this filter, maybe the one which is connected here, and therefore maybe it is simply fine. So one thing I can do additionally, I take it off and let's see what then the behavior of our circuit is. If it is fine, great. If not, we are definitely running out of budget. Okay, I have the little diode here on my test fixture, and yeah, when we test now here the little diode, what we can see is that one side of the diode, so one diode is open, so it is only one diode working, so, and that means one is definitely faulty. So I don't know if that is the reason why our radio will not receive, but it is a kind of odd that you still can see it here on the board, that we had here our dual pack in, so you still see where this dual pack was sitting, and yeah, once again, it is a kind of odd, and I really don't know if one side of this dual pack is open, if that is the reason why the circuit doesn't work, considering that this must be a modification, a kind of modification, because otherwise it wouldn't sit here on book here of these both components, and if they would have forgotten it when they planned here the PCB, well, then we would see it in the schematic, but we don't. So that must be something what has been later added to the radio. Alright, so PCB is back, and you hear static. The radio is connected to our tester, and you see we are feeding minus 70 dBm, and that clearly means it still does not receive. Even we found here our little diode over there, which is not working correctly, but you see we would really need to go deeper, but as I said now several times, we have to cut here, so we cannot go ahead. So that's a bit of a shame, but it is sure that we need additional components, we need additional time simply for preparing testing. You've seen I cannot easily flip here the board over, that I can test from underneath, so that hole would mean I don't know, another hour or even a bit more, and that is now the point where we have to stop. I mean, we saw a little bit of fixing here our final stage. So final stage is working, so that might have been interesting as well. But now we still have our VHF receive issue. But yeah, sorry guys, I really have to stop here. I load it up because that is what sometimes happens as well. So yeah, so it is, that is live, and as I told you, radios like this, I mean this is a twin band radio, and you know that we can get a quad band radio for 250, 260 bucks or so from TYT, and therefore it does not make any sense to go ahead with this radio. Okay, hope it was still